Okay, so now we're talking about holes. We've talked about horizontal asymptotes, vertical asymptotes, and now we're going to add this idea of a hole, all right? And a hole in a graph is where you have a factor, all right, in your denominator, all right? If you have a factor that cancels out in your denominator. So it would have been a vertical asymptote, but since it cancels out the same factors in the numerator on the top, it's a hole. So it's still an excluded value, but you're not going to see it. The graph continues. There's no asymptote. The graph just continues. Normally, it looks continuous. You can't see that there's that one spot where it is actually undefined. All right. And then if you wanted to know the actual coordinates of the hole, right, because it's a point on the graph. If you wanted to know the coordinates, right, you just substitute in the x coordinate, and that would give you the y coordinate of that point, of that hole. Okay. So, and then whatever's left over, right, your leftover in the denominator is going to be your vertical asymptote because it didn't divide out. And here's an example of what I'm saying. You have this rational expression right here, right? And then you factor out your denominator, right? And you get these two factors. And you look at the denominator to get your excluded values. Excuse me. So x cannot equal positive 1 and or negative 3, right? Those will make the denominator 0. So those are excluded values. But notice the x plus 1 factor cancels out. All right, and so in your final answer, you have 1 over x plus 3. So when you graph it, you're going to see your function just looks like this one right here, okay? But there actually is a hole, all right, where it's undefined at when x is negative 3. All right, so let's go ahead and graph that, and you'll see it, and it'll make more sense. Okay, so we put in that function, y equals x minus 1 over x squared plus 2 minus 3. And when you look at the graph, all right, it looks just like our regular hyperbola, right? Which is 1 over x, right? It looks just like y equals 1 over x, although, well, it looks just like this, because that's what's left. Okay, so that's what it looks like. Notice you have your vertical asymptote at negative 3, because that's the factor that's left. Okay, so that's going to be my vertical asymptote, x equals negative 3. Now this guy is going to be the hole. Oops. This guy is going to be, see if I can spell hole. This guy is going to be the hole. All right, so because it canceled out. All right, and so what that means is if you look at your table, go second graph and look at the table. See when x equals 1? Notice there's an error, okay, because it's undefined there. You'd be dividing by 0, and that's just impossible. So even though you can't see it on the graph, it's there. It's a hole. All right. So now we'll go practice some of these where you're just trying to find the vertical asymptote and the hole. All right. So we have, first thing you always do is factor. So I've got, this would be x times x and 3 times 4. I want to have a positive 1, so it's going to be positive 4 minus 3. And then I have an x minus 3 in my denominator. Okay, so that is going to cancel out. So that would be when x equals positive 3, right? That's going to be a hole. Okay, and since everything canceled out, there's no vertical asymptote. All right, so let's put that in the calculator and take a look at it. There we go. Okay, so there's the function, right? Just put it in the calculator, and we're expecting to see no asymptote because it divided out. And sure enough, basically you have this line here, right? You have what was left was just x plus 4. So you have a line with a slope of 1, right, and a y-intercept of 4. All right, but if you look at the table, okay, so it looks continuous, but it's not, because when x equals 3, there's the hole, right? There's an error, all right? But it's different from an asymptote because the graph just looks continuous, all right? It just carries on. It doesn't go to positive and negative infinity, like with a vertical asymptote, all right? So that's all you need to know about graphing these rational functions. All right, and as far as holes and vertical asymptotes. Horizontal asymptotes, there's one last thing. If you have a rational function and you have polynomials, right, and you have exponents, you have different exponents. That is going to, you can tell without graphing it, what is going to happen with the horizontal asymptote. Remember, the horizontal asymptote is, like we said, as x goes to positive infinity and as x goes to negative infinity. All right, so basically as x gets really, really big, what is happening to the function? Well, as x gets really, really big, a -1 doesn't mean anything, right? If you're talking about infinity, right? When x is infinity, and then compared to x to the 5th, x is nothing, all right? And then basically, so this doesn't mean anything, all right? And then since these exponents are different, these don't mean anything, all right? So basically what you've got is that you've got x to the 5th divided by x squared. And so that reduces to x cubed, right? And so what that means is that as x goes to infinity, y is just going to go up to infinity. And as it goes to negative infinity, it goes to negative infinity. All right, so there is no horizontal asymptote, right? If you have a cubic function, right, it doesn't level off, okay? So that would be no horizontal asymptote, all right? So that's if the numerator is bigger than the denominator, okay? You have no horizontal asymptote. Now, if you have the exponent on the bottom that is bigger, all right, so if I switch that, I have the 2 on the top and the 4 on the bottom. Again, we're going to infinity, so these don't matter. All right, and since these exponents are different, these don't matter. All right, well, if I have, so basically that reduces to 1 over x squared. Right? So now if if x is going to infinity, right, what's 1 divided by infinity? Well, is that really big or really small? That's really small, right? If you have $1 and you divide it by, or $1 million, and you divide it by a gazillion people, it's getting smaller and smaller and smaller. One piece of pie, and you divide it into 100 pieces. Each of those pieces is really small. All right, so if you have an infinity in your denominator, it's approaching 0. So your horizontal asymptote would be 0, all right, if the denominator is bigger. All right, so if the denominator is bigger, then it approaches 0. The horizontal asymptote approaches 0. Or is 0. Horizontal asymptote is 0, and your function is approaching 0. All right, because remember, an asymptote never actually gets to that line. So now, what if they're the same? Right? If you have square on top and square on bottom, right? Again, we're going to infinity, so this doesn't matter and this doesn't matter. But now that these are both equal, right? I have x squared divided by x squared. That's equal to 1, right? So now that cancels out. That doesn't matter because it's 1. So what's left is this 2/3. So if there's a tie, right, if the exponents are the same, the horizontal asymptote is going to be the coefficient, the coefficients. All right. So quick practice here. I've got, if I want to find the horizontal asymptote here, I just look at the exponents. So there's a 2 and a 1. Okay. So again, that would reduce, this is nothing as I go to infinity, that basically comes down to be x, right? That's going to go on forever. It's not going to level off. So there's no horizontal asymptote. All right, now this guy, I have a 1 on the top. I'm going to infinity, so these don't matter. That reduces to be 1 over x, all right? So as x goes to infinity, right, as x goes to infinity, my denominator is really big. That's basically 0. Okay, that's nothing. 1 divided by 1,000,000 is 1,000,000th. It's basically 0. So here my horizontal asymptote is 0. And then now this one, this is just practicing with the whole again. Notice you have my excluded values. X cannot equal -12 or 2, right? Those are the two values that make the denominator 0. But this cancels out, so -12 is the whole. See if I can spell it. Whole. All right? And so what's left, right, this is going to be my vertical asymptote. It's going to be x equals 2 is the vertical asymptote. Okay. And if I wanted to know the y value at the whole, I would just substitute into this equation. Right, what I'm left with. If I substitute into there, I get, so for the whole, the x value is -12. And to figure out the y value, I'll just put -12 in here. So that would be 1 over -14 for the whole. Great. And that is the end of Unit 6. Yay, congratulations. Have fun reviewing.